So now we're going to look at graphing a cosine function. And to graph anything in general, the easy way to do it is to come up with a table of values that has your x values and your y values. So that's what we're going to do. We're going to create a table of values for our cosine function. And in this case, our x-axis is dealing with theta values, so angle values. So we're going to pick points off of our unit circle that are angle values. So on my unit circle, I'm just going to pick and choose points. And I'm going to pick points like 0, pi over 2, pi, 3 pi over 2, 2 pi. And I'm going to do one full positive rotation and one full negative rotation, so we can get 2 periods on this graph. So at negative 2 pi, what's our y value? Okay, so this is what we're going to think about. We're going to say, okay, so when x is negative 2 pi, so on our unit circle, when we're at negative 2 pi, what's our cosine value? Okay, so negative 2 pi is one full rotation clockwise. So if we started from here and we went all the way around, we would end up right back here. So what's your cosine value right there? Well, we know the coordinates right there are 1 and 0. And we also know that coordinates are written as cosine then sine. So if we know that our coordinates are 1 and 0, and we know the first number is cosine, then we can say that cosine is 1. So at 2 pi, at negative 2 pi, cosine is 1. And I'm going to do that with green. Cosine is 1. So at 3 pi over 2, going clockwise, so that's all the way here, we're at 0 and negative 1. So in this case, cos is 0. And then at negative pi, so all the way from here to here, we know that that's negative 1 and 0, meaning cosine is negative 1 at negative pi. At negative pi over 2, so that's all the way to here, we have 0 and negative 1, and cos is going to be 0. At 0 degrees, so the coordinates are still 1 and 0, meaning cos is going to be 1. At pi over 2, now we're going counterclockwise, so we're moving this way. So pi over 2, 0 and 1, those are my coordinates, so my cosine value is 0. At pi, it's going to be negative 1. At 3 pi over 2, my cos value is 0. And at 2 pi, my cos value is 1. So now I have a table of values. So the next step is to just plot these points and connect the dots. And that's what we're going to do. So at negative 2 pi, I'm at 1. At negative 3 pi over 2, I'm at 0. At negative pi, I'm at negative 1. Negative pi over 2, back at 0. 0, I'm at 1. Pi over 2, I'm going to be at 0. Pi, I'm going to be at negative 1. 3 pi over 2, 0. 2 pi, back at 1. And now I'm just going to connect all these dots. So this graph isn't going to be 100% accurate because I'm not using graph paper. And my graph continues on this way. So this graph might look a little ugly because it's on regular paper rather than graph paper, but you get the idea. So that's your basic cosine function. And now we're going to look at some key points on this graph. The first thing we're going to look at is, what is your amplitude? Well, we know that the amplitude is your vertical distance from your median point to a max, or your median point to a minimum. So I could go from this point to this point, or I could go from this point to this point, because this is my median right here. So I have to go from median to min, or I could go median to max. So let's go median to min. To median to min, my vertical distance is just 1, because I was at 0, but now I'm at -1. But we don't look at the negative. We just say my amplitude is 1. So my amplitude is going to be 1. The next thing I'm going to look at is my period. So my period for this graph, if we can remember, is that period is your horizontal distance. Okay, so horizontal distance from your max to a min to a min, or you can pick 3 median points. Let's go from max to max. So right now, this is my first maximum point, and it's at 0. I'm looking at my horizontal distance, so I'm at 0. And then my next maximum point is at 2 pi. So I went from 0 to 2 pi, meaning from going from here to here, I moved 2 pi. So then my period is going to be 2 pi because that's my horizontal distance. The next thing I'm going to look at is my domain. So if we can remember, domain is your all your values horizontally. So here, my graph didn't have a restriction. That's why it had the arrows indicating that it went on forever. Okay, so if it's going on forever, when I read my domain, I move from the left side to the right side. So here, my graph is going on forever to infinity, but it's the negative side, so it's going on to infinity in the negative side. So it's negative infinity. And in here, it's positive, but it's going on to infinity in the positive direction. So it's going on to positive infinity. And infinity isn't a specific point on my graph, so it's not inclusive in my domain. It's exclusive. So that's why I'm going to use the round brackets. Okay, now that I have domain, the next thing I'm going to look at is my range. I'm going to go down here. So my range. So range is your vertical, includes your vertical points. So you start from the bottom and you move your way up. So your lowest point on here is -1, and then your highest point is 1. And these are both specific points on your graph that your graph hits. So they're inclusive in your range. So that's why I'm going to put the square brackets. Okay. Now we've got domain and range. The next thing we're going to look at is the zeros of the function. So zeros of the function basically means what are your x-intercepts, or what are your roots. So your zeros, roots, x-intercepts all mean the same thing. So here when I look at my graph, I have an x-intercept at -pi/2, pi/2, 3 pi/2, and so on and so on. So I can't list out every single x-intercept because this graph goes on forever, and that'd just be tedious to list out every single x-intercept. So I'm going to write a general solution that's going to include all possible x-intercepts. And I'm going to do this by writing theta, because my x value is dealing with theta values, so angle values. That's why I'm writing theta equals, then I'm going to write my first x-intercept. I can pick any x-intercept I want, but I'm just going to pick my first one, which is pi/2. Okay, so now I have to figure out how often my x-intercepts are occurring. So I know I have an x-intercept occurring at pi/2, then another at 3 pi/2. So what did I have to do to go from pi/2 to 3 pi/2? Well, I know I just added a single pi. So when I add pi, I'm going to get 3 pi/2. If I add pi again, I'm going to get another x-intercept. If I'm moving this way, if I subtract pi, I'm going to get an x-intercept. Subtract pi again, I'm going to get an x-intercept. So I know an x-intercept is happening every pi, and I can, that's for however many pi's I want to add or however many pi's I want to subtract. So that however many is an unknown variable, and I'm going to call that k. And k is an element of the integers, because integers can be negative or positive, because I can add pi or I can subtract pi. So that's going to be my general solution for my x-intercepts or my zeros or my roots of the function. So the next thing I'm going to look at is my y-intercept. I know there's only a single y-intercept on this graph, and it's y is when y is 1. Okay, that's my y-intercept. And the last thing I'm going to look at is asymptotes. And I know there's no asymptotes on this graph, and then that's all. So one thing to remember is that your cosine graph can either start from a maximum point or a minimum point. And then your sine graph, it can only start from a median. And then that's how you graph a cosine function.